Good afternoon, students. Welcome to this session of revision. This will be the revision for grade 8 maths. Okay. So, grade 8 maths for your upcoming annual exam. So, let's start off with the 1 markers. Then we'll move on to 2 and 4 markers. So, how much is possible in this short video, I will try to cover up and in the upcoming sessions. Okay. So, let's start off with the first question, which will likely be on Pythagorean triplets. So, Pythagorean triplets. So let us say you have a right angle triangle. I told you very clearly that the sides which make up the right angle are the legs. This is leg 1 and this will be leg 2. They make up the right angle triangle. The other side, the longest side or the side which is opposite to 90 degrees is the hypotenuse. So what does this Pythagoras theorem state? That the square on leg 1 added to the square of leg 2 will be square of hypotenuse. In other words, leg 1, okay, 1 minute, let me erase this. Yeah. So it states that Pythagoras theorem states that leg 1 square, leg 1 is nothing but the sides. The non-hypotenuse sides are called legs of the right angle triangle. Leg 1 square plus leg 2 square is equal to the square on the hypotenuse square. So in line with this, we have the triplets we have seen, isn't it? So what can come is, like, I can give you 2 of the legs and I'll ask you to find the hypotenuse. Like, let's just try to recall the Pythagorean triplets: 3, 4, 5, 5, 12, 13. Yeah, 5, 12, 13. Then you have 7, 24, 25. Yes, 8, 15, 17. Then you have 9, 40, 41. 11, 60, 61. It's very important, keeping a 9th and 10th in mind as well. 12, 35, 37. Okay. Then 16, 63, 65, 20, 21, 29. So there are many more. I mean, the infinite triplets, rather, Pythagorean triplets, but we need to know some of these, keeping your 9th and 10th ICC in mind. Okay. So the basic triplets we have is 3, 4, 5. These are the basic triplets. So as in, I can blow them up. I have the blown up version. For example, if I blow up 3, 4, 5 by, let's say, a factor of 2, I'm going to get yet another triplet, 6, 8, 10. So 6, 8, and 10 will also form the sides of a right angle triangle. 6 and 8 will correspond to the legs. The longer side will always correspond to the hypotenuse. So my question can be like, the two sides of a right angle triangle are 6 centimeters and 8 centimeters. Find the hypotenuse. So the hypotenuse will be 10 centimeters. Or I can say the two sides are 5 centimeters and 12 centimeters. Find the hypotenuse. That is two legs, I would say. Legs are 5 and 12 centimeters. The hypotenuse will be 13, isn't it? So then see, 5 and 12 and 13. Then I can say the legs can be 7 centimeters and 24 centimeters. Then the hypotenuse will be 25 centimeters. So that is like this. So I can say 11 centimeters and 60. The hypotenuse will be 61 centimeters. It's not that I'm going to give you like this. I can also give you the blown up version. I can give you 6, 8, and then you will be expected to write 10. Or I can give you 14 and 48, and 25's double is 50. Or I can give you 5's double is 10, 12's double is 24. Then you will be able to give me the hypotenuse for this. That is, when I give you 10, 24, it will be 26. It's a blown up version of 5, 12, 13 is 10, 24, and 26. Blown up version of 8, 15, 17 will be, you can say blown up version by 2, it will be 16, 30, and 34. Now, it's not like you have to always blow it up by version of 2. You can blow it up by 3. Okay, if you have blown up version of by 3, of 3, 4, 5 triplet, what do you get? 9, 12, and 15. You see? So it's not necessary that it's always blown up by 2 or blown up by 3. Anything. It can also be blown down. It can be 1.5, then you can have 2, and you can have 2.5. So just be careful here. You should know these triplets. Whenever I give you the two legs, see by which triplet it will match towards, and then accordingly get the hypotenuse. If I give you 5, 12, and 13, if I say blown up version by let's say 2, what will it be? Then if you blow up 5, 12, 13 by 2, you will be getting 10, 24, and 26. All right. Just keep this in mind. So you must know the Pythagorean triplets. Just let's quickly reiterate this. So it's 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41, 11, 60, 61, 12, 35, 37, 16, 63, 65, 20, 21, and 29. Okay. I'll just move on to the next page. Yeah. So those of you who haven't made a note of it, it's better you make a note of it now. So the triplets will be, I'll just write it down here. Okay. So 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41, 11. I'll just put a line here. So we are moving on to 11, 60, 61, 12, 35, 37, 16, 63, and 65. Then 20, 21, and 29. Okay, so you can have many more, but it's good to know these and we can work around these. Okay, so you will find them useful in later on also. You'll in trigonometry, in mensuration, and then in triangles, in congruency, similarity, and all of this. So it's good to know the Pythagorean triplets. Remember, the first two sides correspond to the legs. The next one corresponds to the hypotenuse. Okay, so I'll just move on to the next question. So students, let's move on to the next type of question. This is based on exponents. As you can see, so we need to know the law of exponents. This was done way back for both 7th and 8th. This was done way back, I think in June, July, I have done this chapter. So a to the power of m into a to the power of n would be a to the power of m plus n. Okay, we'll adopt that here. And if I say a to the power of p is equal to a to the power of q, I can, the bases are same, so I can equate the powers, isn't it? So I can say p is equal to q. So, okay. So when bases are same, so a is like what? -3, no? And this is the exponent here, and this 5 is the other, m plus 1 is an exponent, and 5 is the other exponent on the left-hand side. On the right-hand side, I have 7. So I can write this as -3 to the power m plus 1 plus 5 is equal to -3 to the power 7. So I am adding, isn't it? So I'm taking the same base and I'm adding both the exponents. That will be -3 to the power m plus 6 is equal to -3 to the power of 7. Okay. So I'll just scroll down. Yeah. And now the bases are same. Equate the powers. M plus 6 is equal to 7, which means m is equal to 1. So you just use simple laws of exponents here. When the bases are same, you're going to equate the respective powers, and you have used a to the power of m into a to the power of n is equal to a to the power of m plus n. All right, there are many more laws. We'll not be using all of it because we have to cover other topics also in the exam. But it's good to know, especially those who have taken up science stream. Children, it's good to know the laws of exponents, revise the laws of exponents, and make sure that you know all the laws and their applications. Okay, let's move on to the next question. All right, students, let's move on. The next thing is test of divisibility. See, when I give you any number and I ask you to find out whether it is divisible by 3, for example, okay? If I say, let's say 347, I'm just taking a random number. So I'm asking you, tell me whether it's divisible by 3, let's say. Now I told you, you can perform the division, 3-digit number, not a very big thing, but you can also, because I'm not asking for the quotient and the remainder here, I'm asking you to find out whether this number will go by 3. So what I can do is I can apply some checks or tests, which we say tests of divisibility. If I want to find out divisibility by 3, then what do? I add the numbers. The sum of the numbers should be divisible by 3. 3 plus 4 plus 7 is what? 3 plus 4, 7 plus 7 is 14. Will it go by 3? No. 14 is not divisible by 3. So 14 will not go by 3. When the sum of the digits is not divisible by 3, the number itself will also be not divisible by 3. So the divisibility test fails. So like this, I can ask you a question. Now, let's say I'll ask you by 9, the same thing. If I say 340, let's just change a bit here. 342, for example. I want to know whether it is divisible by 9. Now, for divisibility by 9, the same logic, the same test holds good. Meaning to say, you add the digits, and if the sum of the digits, now what is the sum here? 3 plus 4, 7 plus 2 is what? 9. 9 is divisible by 9. 9 ones are 9, isn't it? If the sum of the digits is divisible by 9, the number itself is also divisible by 9. So it works out here. I really don't have to go and perform the division process. That's fine. I can perform the division process. The test of divisibility, this tool is actually helpful when we have huge numbers. So let's move on to actually what I would be testing on. Let's say I'll give you a number like let's say 1, 4, A, and let's say 11, 7, for example. Okay, 1, 4, A, and 7. And I'm telling you, my question is like the smallest value of A, so that this will be divisible by 9. So how do I know what is the smallest value of A? Now I can say 1 plus 4 plus A plus 7. So sum of the digits should be divisible by 9. If this digit, now remember A is a digit. A can take on any value from 0 to 9. There are 10 digits from 0 to 9, remember. Now A can take on any one of the values, right? So now we have to find out what can be the value of the smallest value of A. We might have more, we can have more than one possibility. The question is the smallest value of A, so that this test of divisibility is satisfied, that is by 9, when it is divisible by 9. So what do I do here? So I'll have to add the digits and see which is the smallest or the nearest multiple of 9 that I can get, isn't it? So let's add. 1 plus 4 is 5. A is variable. Keep it for a side for now. 1 plus 4 is 5. 5 plus 7 is 12. Okay. So 12 plus A. Now, 12 plus A. So A is something that I'm going to add. Let me see. It's some digit. It should be some digit from 0 to 9 only, isn't it? And when I add that A to this 12, I should get a multiple of 9. Smallest multiple. Now, if you can analyze 12 plus 1, no good. 12 plus 2, we get 14, no good. 12 plus 3, 15, no good. Okay, like that. Now, if let's say 12 plus 6, what do I get? 18. Yeah, 12 plus 6 is 18, which is the nearest multiple of 9 that I can get, isn't it? So if A is 6, I get 1467 as the number. And when I add them, of course, I'm going to get what? 18 as the sum. So this number will be divisible by 9, because 1 plus 4 plus 6 plus 7 gives me 18, which is divisible by 9. And so the entire number as such will also be divisible by 9. So you should be able to do this. Add the digits and see the nearest multiple of 9 and see accordingly which value of A will hold good for this. All right. See, by the way, I'm talking so much about all these 1 marker. These are all MCQs, students. Okay, so that since you're going to get these 4 options, you have to choose the right option. Not that we are really going to look into the working. You can do the working by the side, not on a separate paper in the answer script. I've informed all this to you earlier. So you make a rough working column on the right hand side of the paper, and you can perform all the rough operations there. Because for 1 marker, we are not going to really look into the working. You just put the correct option, whether it is option, let's say option question number 1, option D is the right answer. Question number 2, option C. Just this much is enough. We're not going to look into the working. Just put the right question number and the option against it. Okay. So this is what it is. So you have to look at test of divisibility. So I've asked you for test of divisibility by 9. But remember, it's good to know the test of divisibility by all numbers from 1 to 11. There are many more. If you look at number theory more in advance, you'll get test of divisibility by 13 and all this. It's not required for you. You should know test of divisibility for numbers from 1 to 11. And I have asked you for 9 in the assessment, in the exam. Next, moving on to question number 4. This is to do with circles. So I spoke about different circles and the lines, relationship between the line and the circle. You can have a circle and you can have a line. The circle and the line, there's nothing big. The circle goes about its own business. The line goes about its own business. Then you can have a circle then there's a line which is striking across the circle, which cuts through the circle. And when it cuts at two distinct points, isn't it? Point A and point B. In maths, we actually use the word intersect. I said the word intersect. This line which intersects the circle at 2 points, so distinct points, it's called as a secant. Yeah. And then when I take the endpoints, that is this points of intersection, and I consider this line segment, it is called as a chord. We discussed all this also. Yeah. So you should know what's a secant, what's a chord, and also then you also have a case where really the line doesn't cut at 2 points or doesn't intersect 2 points. It just touches the circle at one and only one point. It touches. That's called as a tangent. Yeah. It's not cutting it at two distinct points. You see, just touching the circle at one and only one point. I mean to say there's only one point common to the circle and the line, that's called as a tangent. Okay, so you should know this terminology. All right. So moving on, we have we have a line. I I discussed this with you regarding lines and bisectors. So a line, if I give you, let's say, uh, line segment, let me restrict it a little more. So let me say a line segment. I have a line segment. Let's say AB is a line segment. Remember, line segment AB will have infinite bisectors. Yeah, you can have many bisectors. Bisectors are those lines which will cut the line into two halves or two equal parts. So you have infinite bisectors. You can have infinite perpendiculars. You can draw infinite perpendiculars to this line. But when when I'm talking about a line in particular, which is perpendicular and a bisector, that is a perpendicular bisector, there's one and only one line which is possible. So that means a line segment can have infinite bisectors. It can have infinite perpendiculars that can be drawn onto it. And you can have only one and only one perpendicular bisector. That line which is acting both as a perpendicular and as a bisector. I told you, right? You can keep your compass and point at A, you know, and you open out the compass and the pencil end. See that you take the span of a little more than half, approximately, cut an arc above and below, the same thing. And then you keep that, don't change that span of the compass, keep that pointed end at A, and then cut the former arcs so that you get you get 2 points. And you can, when you join the 2 points, the line that you get is a perpendicular bisector. So this is just the geometry part of it, but of course you can actually draw it and you can explore for yourself and see. So it'll have infinite bisectors, infinite perpendiculars, but one and only one perpendicular and bisector. One perpendicular bisector is one and only one. Okay. All right. Let's move on. So next we discussed about yeah, it's about the SAT technique. So I told you when it comes to quadrilaterals, whenever you want to describe any quadrilateral, you have to talk in terms of SAT, that is sides, the angles, and the diagonals. So if I ask you a simple question like, name the quadrilaterals where the diagonals are equal, there are three of them, isn't it? The three diagonals are, one is your rectangle, one is the square, and the other is the isosceles trapezium. We have seen this when we did quadrilaterals chapters where I think it's in August, yeah. So isosceles trapezium, these three are the quadrilaterals where the diagonals are equal. But when I say name the two parallelograms in particular, because isosceles trapezium, of course, is not a parallelogram, so it will be rectangle and square when I talk about parallelograms. All right. But my question here would be, I'll give you a few things and I'll say, find out the diagonals are equal in which of these. Let's say I can give you a rhombus, I can give you a kite, I can give you a square, I can give you a rectangle, and then I can give you this one. Yeah, trapezium. So, and I didn't say isosceles trapezium, right? Until isosceles trapezium, you should not assume anything. Just because I say quadrilateral, you shouldn't think it's a square, right? So if I ask you, I'll just write it down again. We have a square. We have a trapezium. I'm just writing out some quadrilaterals for you. So this is a rhombus. And then you have your yeah, rectangle. And right. Okay. We've discussed all the types of quadrilaterals. We have seen their properties also. So what's important is now Out of this, there are 3 parallelograms. Parallelograms are square, rhombus, and rectangle. You can see. All of them are, of course, quadrilaterals. But then the parallelograms are square, the rhombus, and the rectangle. Now, diagonals are equal only in square and rectangle, remember. And don't write trapezium because I did not say isosceles trapezium. Isosceles trapezium is a special type of trapezium where the non-parallel sides are equal. Since I've not mentioned anything, don't assume anything. You can just go with. All right. So you should know this. I think I made you all write the SAT technique down in class. You should know the SAT technique so that you will, yeah, 1 minute. Yeah. So you'll be able to get familiar with this. I've shared this with you. So I don't want to write it down again. If you can look into your notebooks, you can see I made you write on the SAT technique that is for square, rectangle, and rhombus. So where you see how there's if I just ask you like why the square and the rhombus are how are they same and how are they different? So square and rhombus are same in 2 ways. One is square and rhombus have the all in both the quadrilaterals. I mean the number of sides are the sides are all equal. In square, all the 4 sides are equal. Even in rhombus, the 4 sides are equal. The next coming to diagonals. In square and rhombus, the diagonals meet at 90 degrees. That's very important. Okay. So, but then how are they different? In square, diagonals are equal. In rhombus, the diagonals are not equal in length. And again, in square, all the vertex angles are 90 degrees, but in rhombus, they aren't. Only the opposite angles are equal and adjacent angles are supplementary. If I ask you about square and rectangle, in square and rectangle, all the sides are not equal. In rectangle, that is only opposite sides are equal. In square, all sides are equal. Then that's one difference. And again, in diagonals do not meet at 90 degrees in rectangle. In square, they meet. And how are they similar? They are similar because in both square and rectangle, the diagonals are equal in length. So both the diagonals are equal in square, both the diagonals are equal in a rectangle. And one more similarity is the vertex angles are all equal. So whenever we talk about the properties of quadrilaterals, remember the sides, remember the angles, remember the diagonals. So it's a technique. So with this, let's move on. Now you should know numbers which are perfect squares and also perfect cubes. For example, when I list out a few perfect squares, like say 1, 4, 9, 27, 64, and so on. I mean to say, I'm just writing the numbers. Okay, I'm not saying perfect square. I'm just writing the numbers here. So 1 is a perfect square and a perfect cube. 4 is only a perfect square. 9 is a perfect square. 27 is 3 cube, isn't it? It's a perfect cube. And 64, when it comes to 64, just like the case of 1, 1 is a perfect square and a perfect cube. 1 cube is equal to 1. So likewise, 1 square is also 1. 64 is also a perfect square and a perfect cube. 8 square is 64 and 4 cube is 64. So 1 and 64 are perfect squares as well as perfect cubes. But if I give you, let's say, 729, okay, that will be 9 cube. 9 into 9 into 9. It's a perfect cube. How about 27 square? 27 square is also 729. So that means it is a perfect square and a perfect cube. But then if I give you a number like 125, 125 will be 5 cube. And it is not the square of any number. It's not a perfect. But there are certain numbers which are both perfect squares and perfect cubes. But certain numbers are not perfect. They're not both. Okay. You should know that. Or if I give you, let's say, 625. 625, it is 5 to the power of 4. Yes. So, or it is 25 to the power of 2. Let's not go to power 4 now. That's not needed now. 25 square is 625. But then there's nothing like the cube of something is 625. Got it? So 625 is only a perfect square. It's not a perfect cube. But numbers like 164, then we have seen 729. These are all perfect squares and perfect cubes. All right. Then you all know about Hardy-Ramanujan number. Made you all write down in the class. You should be knowing it. So I can just jumble up the numbers. So you should know. Be very careful. Hardy-Ramanujan's number is 1729 because you can express it as 10 cube plus 9 cube. That is 1000 plus 729. Or you can also express it in the smallest number, which can be expressed as a sum of 2 cubes. That too in 2 different ways. Or I can say 12 cube plus 1 cube. That's why I told you, you should know the cubes of the first 28 numbers, first 25, first 12 numbers, and the squares of the first 25 numbers. Squares of the first 25 numbers, cubes of the first 12 numbers. You should know this uh, to help you understand these concepts. So plus 1. So these are this is the Hardy number. You have many more numbers. Okay, this is the smallest number that we have. Smallest Hardy Ramanujan number. The next one is simple interest. So when I ask you a sum on simple interest, SI on, so I can give you the principal. I'll give you the principal. I'll give you the time. I'll give you the rate of interest. So remember, when I give you P, that is principal, the time, remember, time will be in years. If it's given in months, you have to convert it to years. If it's given in months, divide by 12, you'll get in years. And rate of interest per annum. So whenever you have this, you can compute this by saying simple interest is P into T into R, or I would sometimes just say PTR upon 100. Principal into time into rate of interest by 100. So this is the simple interest. And what is amount? Amount is principal plus simple interest. So if I give you the principal, if I give you the time, if I give you the rate of interest, then you should be able to compute the simple interest and the amount. So if I say find this, okay, I can ask you a question like on a particular, let's say, find the simple interest and amount on rupees, let's say rupees 300. Okay, for let's say time is 4 years. So since it's a one marker, it will be very straightforward. The principal will be given. That is the principal is the investment, and then the time is 4 years. Rate of interest will be, let's say, 5%. Okay, per year or per annum. And you need to compute what? You need to compute the simple interest and amount. So remember, the question is both. All right. So if you compute the simple interest correctly, only then your amount will be correct, because amount is P plus SI. If SI is incorrect, the calculation for P or the amount also will go wrong. What is SI? P into T into R by 100. Straightforward. So it will be what? 300 into T. T is 4 into 5 by 100. What will that be? 100 ones are 100 threes are. So 5 4s are 20, 23s are 60 rupees, isn't it? So it will be 60. Yeah. So that is the SI. And amount will be, so since SI is rupees 60, what will be the amount? Amount will be 300 principal plus SI, isn't it? That will be principal is 300 plus 60, which is rupees 360. Okay. Yeah. All right. So this is it. Then so remember, you should get the correct correct SI, I mean, and then P plus the SI will give you the amount. So I can ask you for, so remember, I'm still talking about MCQs. So 4 options will be given. See the correct option, the answer, and then write the option against the question number. Then coming to probability of an event. See, probability of an event cannot be, I'm asking you I'm saying probability of an event cannot be what? The probability cannot be negative. Yeah. Probability cannot be a improper fraction like 5 by 4. It's not possible. Negative numbers like -3 and all can't be the probability. You cannot have probability more than 1. You cannot have 1.5 like that. You cannot have probability which is improper fraction. But you can have probability as 0. 0 is for a impossible event, and for a sure or a certain event, the probability is 1. The certain or a sure event, we have seen, these are too extreme, of course. Otherwise, in general, probability will lie between 0 and 1. So when I give you options, when I say it cannot be, remember, probability cannot be, let's say 1.5, it can't be like that. What about probability of 30%? Now 30, you can't say 30 is greater than 1. We're talking about percentage, right? I told you what is A percent. A percent is A upon 100. When I say probability of something is 30%, 30% means 30 upon 100. 30 upon 100 will be 3 upon 10, which of course condenses to 0.3 in the decimal form. So which is less than 1, isn't it? So as long as it is more than 0 and less than 1, more than or equal to 0, because 0 is also allowed, no? And less than or equal to 1, then the probability, that number can be the qualified to be the probability of an event. So if you have negative numbers, if you have improper fractions, if you have something like 1 point something, 1.2, 1.3, etc., you can't have that number to be the probability of an event. So you should know this. Moving on, next question are the sum of 3 consecutive odd numbers is 51. Find the numbers. So I can give you like 3 consecutive odd numbers. They add up to, sum means addition, right? Product means multiplication. 3 consecutive numbers add up to 51. Find them. Now be very careful. I'm using the word consecutive. Uh, if I say odd numbers, if I say just numbers, what would you do? You would have taken x minus 1, x and x plus 1. Now I'm using the word odd numbers. So you should be very careful here. So even numbers differ by 2. Odd numbers also differ by 2. So if one number is x, the next odd number after it will be x plus 2. The odd number before x will be x minus 2. And I'm going to add all of them and I should get what? Yeah. Let me just add them. X minus 2 plus x plus 2 is equal to 51, isn't it? So I should not take, if I say just numbers, consecutive numbers, you can take x minus 1, x and x plus 1. So be very careful when I use the word odd or even. You have to differ them by 2, right? So now minus 2 minus plus 2 will cancel. 3x is 51. So that's why I told you be good with tables. 51 by 3 is how much? 17. So when x is 17, the other numbers will be what? You have 17. The other number is 17 plus 2, 19. And this side, what you have? 17 minus 2, which is 15. So now I'm discussing so much of, so many different types of problems. Please keep it in mind that the same numbers might not come. I'm just giving this revision for you all to practice and understand the nature of the question paper and make it a little easy for you. You're all preparing well at home, isn't it? So you're getting help from your parents and other sources. You might be referring books and so on. My intention is that you practice. You can also use this as a resource practice. Please don't get into the notion that the same numbers have to come and then don't say, ma'am did discuss this. We have discussed a lot of things. I've done a lot of revision. I'm doing this also just to help you all because some of you asked me for this content. Okay. So you should know the method. If you know the method and what I'm discussing here, it will help you to do the similar sums. It doesn't matter if I'm going to change the numbers. If you know the methodology, you can apply the same logic to different numbers. So now that I'm going to ask you 51 itself, I can ask you something else in the question paper. Moving on. The next thing is your a very simple topic. It's like this is on this. You think I think you sail, you or I think and you sail. That is, I think you got it. What I'm trying to say, that is on direct and inverse variation. So I'll be giving you a question, maybe on direct, maybe on inverse, just to discuss with you all. Let's say I'll give you a question like it takes let's say 50 hours uh, to complete a project, to complete a task with, let's say, 20 laborers or 20, let's say 20 employees. Okay, I'm just giving you a number like this. So if you employ 20 people, there's some task, some project, it will take about 50 hours to complete that task. Now, how many employees needed to complete the task in, let's say, 40 hours, for example? It's a very straightforward question. So I told you, write the parameters, make a table like x, comma, y. X is for hours, y is for employees. So what is the first scenario? There are 20 employees, isn't it? And it is taking 50 hours to complete the project. Next, what is the scenario? Um, it is decided that we don't want to go with 50 hours. We want to complete it earlier than that. We want to finish the project in 40 hours. Then how many employees are required? Yeah. So this is like your x1, this is x2, and this is your y1, and this is y2. Inverse proportion, isn't it? More, if you have more employees, you can complete the task in more hands to help. The work is faster. It takes lesser time. Time is less. Employees are more, time taken is less. Employees are less, time taken is more. So it's a case of inverse variation. X1 into Y1 is equal to X2 into Y2. Isn't it? X1 into Y1 is equal to X2 into Y2. So it will be 20 into 50 is equal to, what is X2? So X2 is 40. x1 is 50, right? Or you can write 50 or 20, multiplication is commutative. Not to confuse, you can write like this. You can write 20 into 50 into 20. 50 is equal to, what is it? This 40 into y2. So y2 is the number of employees required, isn't it? So I want the project to be finished in 40 hours. So I'll require, naturally I'll get more, I need more employees. Let's see how many more. 40. Bring the 40 down. So what will happen? So so 21s are, 22s are, 2 ones are, 2 25s are. Yeah. So 25 is equal to y2. y2 is 25. Y2 corresponds to the number of employees, isn't it? Y2 employees, see, 25. So it is 25 employees are needed to complete the task in 40 hours. It's more than, see, if it's 50 hours, you have 20 employees. Now that you want to complete the project in lesser time, you will require 25 employees. That means 5 extra employees are needed in this case. Okay. So with this, I've covered all the 1 mark type of questions. So I hope children it will be helpful. So I will get back to you with two markers now in the next session.